Hello ladies, in this video we're going to go through a bit of theory for 7F and some of the questions for 7F as well. So 7F is looking at the least squares regression line to model linear association. Now, just before I get into, and I don't want to read to you because I know you can read, but it is extremely important that you do read the theory in here because it does explain what it means by doing a least squares line. Now, when we were looking at scatter plots, and let's just scroll up and have a look at one. So, don't know how. Okay, so here are some scatter plots, and you can see none of them are a straight line. Okay, but in 7D, we're kind of looking at, well, what would the strength of the association between these two variables, what would they be? So the strength in A, you can see that's a lot stronger than what it is for B. So the dots are very close together, which means they kind of form a straight line. So as you know, your explanatory variable increases, your response variable is also increasing at basically the same rate. But when you get more scattered like this, you know, the relationship is weakened, and then you can see in D, there really is no relationship. So the least squares line basically just puts a line of best fit. It goes in between all the dots, and you use that line of best fit to model what will happen. And these sorts of things are used all the time in statistics because we always want to predict what's going to happen in the future. So when you think of what's happening now with COVID, is, you know, we need to make predictions about what's going to happen, not so much, you know, oh, well, we need to know what's happening with the virus, but we also need to know what's happening with the economy, what's happening with our health system, and people need to predict. They just don't wake up in the morning and say, bring it on. They say, we need to be prepared. So we use the least squares line to predict what's going to happen in the future. Okay, so let's just scroll back down to 7F. Okay, so that's basically what the theory is talking about. The least squares line, what it basically is, and this is in your notes, is it looks at minimizing the distance between your actual values, which are these dots here, and your predicted, which is made by this red line. Okay, so it aims to minimize that distance as much as possible. That's where the least squares comes in. Now, these arrows, these blue lines, are what we call the residual. That will make more sense when we actually cover residuals. We did do a bit in class where I said the residual is the difference between your actual and your predicted. So if you've got an actual value above the regression line, as we do here with these three dots, your residual is going to be positive. And if they're below, your residual is going to be negative. But basically, the closer those dots are to the line, the lower your residuals are going to be. Now, when we start doing more on residuals, that will make more sense. But you do kind of need to know what a residual means. And when you think of the definition of residual, it's just what's left over. Okay, so residual is what's left over. So this is kind of like, well, what's the difference here? All right, this little box here is, so usually we'll do the least squares line on the calculator, but you also need to know this formula. Now this formula I'm going into year 12 now, further maths, is on your formula sheet. I'm pretty confident it's on your formula sheet. And often you'll get a question that does ask you to use this. And sometimes students are like, what is this? That just means you've forgotten about it. You need to remember it exists. So when you start seeing a question that refers to B, R, S, Y, S, X, blah, 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 it's a straightforward formula question. You just plug things in and it spits out the answer for you. Okay, so there's two ways you can get your regression equation. One way, and the most used way, is just using your calculator. And the second way is using this formula. And this formula isn't that difficult. You just need to know how to use it. The dot points down the bottom do tell you what each thing is. So when B is our slope, A is our intercept. Okay, so R is the correlation coefficient. Sx and Sy are your standard deviations of X and Y. And X bar and Y bar, so bar, just the bar on top, means the mean are the mean values of X and Y. So we just use the standard deviations and the means. Okay, so that'll probably make more sense when we do some questions. Again, just these 2 points. Least squares regression lines only apply to scatter plots, so your variables have to be numerical and the association has to be linear. If it's not linear, we do what's called a transformation. And we're not doing transformations just yet, but when there's association that is curved, we do a different model for it. So not all in life, things aren't always going in a straight line. They're, well, more often than not going to be curved anyway. Okay, so that's just that part there. All right. We did do this example in class, and the way your calculator does it is a little bit different to how I would usually do it. The good thing about this method, though, that the calculator has shown is that you can actually see your scatter plot and you can see that line, and it's already put the equation in for you. So the other method, which I'll show you shortly, and I did show you in class, doesn't give you the equation. It gives you the value of the slope and the y-intercept, so you need to plug them in. But this method actually puts the equation in. However, it doesn't give you r or r squared, so there is a way of doing that, and that's what this this other screen is. I'm sure there's more than 2 screens there. Okay, so when we do some questions, I'll talk you through that. That is just for the other calculator, so I'm going to keep scrolling. All right, so I just want to read what it says up there. Okay, so significant figures. All right, that's important. I haven't read that whole thing, but I think it's talking about significant figures. Significant figures will always be tested in regression. Okay, it's on the study design for further maths. It's something that is assessed, and it's usually assessed in this. Okay, so you need to know we're not rounding to decimal places, we're doing significant figures. Okay, so you'll see here it's asking for significant figures, and I'll explain that in a little while when we get to it. All right, so let's have a look at question 1. So the table below shows the weight and blood glucose level of 8 adults. So construct a scatter plot to display these data with weight as the explanatory variable. Okay, and then we're going to fit a least squares regression line to the scatter plot and determine its equation. Write the equation, giving the coefficients to 3 significant figures, and then determine the correlation coefficient to 3 significant figures. Okay, so let's just get my calculator up. I'm going to clear that we don't need. I'll make it smaller too. So new. Now, when you're doing stats, it's always a good idea to start a new document. Otherwise, you're going to have so many variables on your calculator, and it's not going to really overwhelm the calculator. The calculator is pretty switched on. Not saying that you're not switched on, but you can get confused if you've got a lot of variables in there and they kind of get lost. So always just start a new document. Add lists and spreadsheets. So that's where we put our values in. Okay, so when you're putting in your variables, try to get into the habit of just using the variables as they're written. It does require a little bit of typing, but again, reduces any confusion. All right, let's put those values in. So 82.1, 70.1, 76.6, 82.1, 83.9, 73.2, 66, you don't need to put 0.0 in, and 77.5. Okay, so it did say in the question we had 8, so 8 adults, so just making sure there was actually 8. All right, and then we put in the glucose. Okay, oh, I was going to read them out so you didn't have to, sorry, keep looking, but all right, so do a double check, just make sure there's no errors. Looks good to me. All right, so I'll show you both ways. Oh, you can't see the computer screen, calculate screen. Let's just make it bigger here. All right, so I'll show you both ways of getting it. So let's first draw our scatter plot. So control, add page, data and statistics. So looks like this now, but we got to add. So down the bottom is our explanatory variable weight, and then our response variable glucose on the y-axis. So there's our scatter plot. Now to put in your equation, go to menu, analyze, regression, show linear a plus bx. Try to keep it, I mean, you could do mx plus b, but usually regression equations are written in the form a plus bx. So we'll just put that in. There's your equation to many, many decimal places. Whoops. Oh, just trying to grab it. Grab. Why can't I grab it? Oh, there we go. It's waiting for the hand to go down. So you can see we've got heaps of decimal places there. It's a bit annoying, but the more the better, because you don't want to be rounding incorrectly. So the equation's there for you. So let's just see if I can, oops, make this smaller and write it in. Okay, so I'll write it in over here. So we tend to not use y and x. So y is your response variable. So in this case, glucose. And I've got to check how many decimal places we've got to put it to. Oh, sorry. Okay, so 3 significant figures. Oh gosh, sorry, wrong thing. Okay, so 3 significant figures. So let's just write the numbers down. So we've got 50.813118, and it's going to keep going. 3 significant figures means we look at the first 3 numbers. So it's not 3 decimal places, it's significant figures. So that's 1 significant figure, 2 significant figures, 3 significant figures. Okay, so we always start with the non-zero. So 5 is a non-zero, and it's different if you've got zeros there, and I'll explain that because I can see the value of B is starting with 0. So we've got 50.8. Just be careful with rounding. So if you needed to do rounding there, you would have to do it. Plus, now your value of B, or your coefficient, is 0.61569. You don't have to write all those numbers. Now, significant figures, remember before I was saying we don't include the zeros. So if your first number is a 0, we miss it, skip it, and just go to the next number. So we're going to be doing it to those 3 numbers. And because this number is 5 or greater, we're going to have to round up. So we're going to have, still keep that 0 there, but significant figures 615, but that 5 rounds up to 6. So it's going to be 616. And then your x variable, your explanatory variable, was weight. Okay, so this equation is this straight line here, okay, to 3 significant figures. Now, if you wanted to do R, I would go back to your screen, and I'll just make this bigger so we can see it a bit easier. Oh, sorry, I just realized my recording screen isn't the width of my computer screen, so it makes it a little bit harder to see. Okay, so we're on this screen. Go to menu, statistics, stat calculations, and then linear regression A plus BX. Just put in your variables. So we've got weight for X, glucose is Y, and you got your same values here, okay? So just like we did before. And now they've also given us R squared and R. So the next part of the question was stating what R is. So R is 0.570. Now, to three significant figures, you need to include that 0 on the end, okay? Because remember, we don't count any leading zeros, but we do count the zeros on the end. And that's because, you know, if we only did it to 5.7, we don't know what this number is, okay? So putting 0 actually signifies that, you know, it is there, it does exist. So 3 significant figures. And that's not rounded because the next number is a 4. Okay, so if you need a bit of revision for your rounding, then do so. Okay, so that's how I would usually get the equation. I think it's a good idea to use the scatter plot to get your equation, to use this to get R. Now, the other way you could get R, if I just go to, and this is what the calculator is saying, you can, what is it, stat R, let me just check what it was. Oh, var, set, okay. So we do var, and then we want stat R, and there it is. If you wanted other things, so I've never actually used this before, girls, but I can see you can get R squared. What else can you get? Your value of A, your value of B, but I mean, you've already calculated all those things, so you're kind of just doing the same thing again. Just see what else is on here. Anything worth noting? Not really. Okay, so yeah, just you could, another way of doing it, but I would do it through your stats list, getting R and R squared. All right, let's have a look and see if there's any other questions worth doing. So let's just scroll over. I feel like I'm all over the place with all these screens. Yeah, there we go. Make it a bit bigger. All right, so we just did question 1. Question 2 is quite similar. I don't think there's anything really different with them. Just make sure that if they don't state what the explanatory variable or response variable is, that you can work out which one is which. All right, girls, bye.